You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Jacob Haqq-Misra. Jacob Haqq-Misra is a senior research investigator at the Blue Marble Space Institute of Science. As a member of the American Geophysical Union and the International Astronomical Union, his research focuses on understanding the conditions that allow life to survive on Earth and the possibility of detecting signatures of biology or technology on other planets. He also studies the possible futures of life in the solar system. He received his MS in meteorology in 2007 from Penn State University. He received his PhD in meteorology and astrobiology in 2010. He enjoys playing music as a drummer and vibraphonist. He is a member of the psychedelic rock band Mystery Train. In today's episode, John is joined by Dr. George Profitiliotis. Dr. George Profitiliotis is a research scientist and future studies expert at the Blue Marble Space Institute of Science. He has worked extensively in the fields of strategic foresight, futures literacy, and future studies. He is particularly interested in applying techniques from those fields to the domains of anticipatory governance and anticipatory ethics of advanced technoscience.
Jacob Haqq-Misra and George Profitiliotis, welcome to the program.
Thanks so much, John.
Thank you. Glad to be here.
The rethinking the infamous Kardashev scale. And many years ago, Kardashev formulated it based on the idea of energy usage, or energy harvesting. And he had, of course, the famous type 1, type 2, type 3 civilizations. And we are not yet at type 1. But, and this has been raised a lot before, that it is an imperfect scale. It's more of a thought experiment than anything else, a way to frame it. Gentlemen, you have reframed it in a different way, a re-envisioning of a kind of Kardashev scale. Can you give us an overview of that re-envisioning of how would you judge an alien civilization based on energy use?
Well, the way we started approaching the problem is thinking about how, the Kardashev scale, Kardashev's original paper, he's thinking about a civilization that's expanding its energy use. But he makes a comparison to a spatial scale. And in many applications of Kardashev's ideas, people think about the spatial scale. So, a civilization that's using the amount of energy incident on its planet from the star. There's also a spatial scale of being on one planet. And then if you're using all the energy output from your star, you build one of these Dyson sphere, Dyson swarm elements or something else like that, or just using that amount of equivalent energy. That's the type 2 civilization. And then the spatial scale is the whole solar system. And then the type 3 being, the energy output of a whole galaxy corresponding to the spatial scale of the whole galaxy. And, there's been searches for this, looking for type 2 and type 3 civilizations in astronomical data to see if you find anything, imagining that the civilization is not only using that amount of energy, but that it's doing so across, for example, a whole galaxy. And so we just take these two dimensions and separate them and, point out that one could increase energy use and keeping your spatial scale the same. One could increase your spatial scale without changing your energy use much. And then there's a lot of options in between. So it's kind of this two-dimensional space where the Kardashev scale is really telling you a maximum. That's the maximum amount of energy you can get out of starlight. And you may not be at that limit. You might be somewhere below it at any amount of energy use or spatial scale.
Which is where we're at, meaning that we have not hit type 1. And it is possible, and you present this idea, that maybe we won't. Maybe there isn't a reason. Maybe there is something that blocks it. So you came up with scenarios of the human future, which is, of course, you can only go so far with that, but scenarios of the human future so that we might be able to recognize and rethink what to look for in regards to technosignatures. George, what's your view on that?
Yes, exactly. We started this line of work figuring out that perhaps we could use the multiple futures of the Earth's technosphere as analogs for looking for other kinds of technology-capable intelligences, let's say. And the first step to do that was to acknowledge that the future of the Earth's technosphere, which is the totality of all the technological mass systems, artifacts, and other kinds of interactions that all these kind of technologies have, does not have to be a single trajectory and does not have to be predetermined, which is kind of what this underlying philosophy of progressionism sometimes takes as an implicit assumption. So we wanted to challenge this implicit assumption and say, well, let's have a deeper look and see what are the different plausible trajectories that the Earth's future technosphere might have, to broaden up a little bit our perspective, which is also what the field of future studies does. It's the main reason that the field exists, to open up, let's say, the possibilities of the future instead of having people predicting the future or thinking that the future is a predetermined trajectory which just pulls us forward. So this is how we started this line of thought, to just dig deeper into the assumptions to see whether we can reframe them and produce plural perspective, let's say, that could help the field move forward.
Now, in looking at these scenarios, were there any common threads among all of them? And I would advance energy usage, increases in energy requirements as your civilization advances. Are there threads that weave through all of the scenarios that seem to be a defining factor in a way, as in Kardashev with energy usage?
Well, one, we talk about growth rates, and that's, is it a defining thread? I think, there's kind of groups of these scenarios when we think about the growth rates. Kardashev assumed a 1% growth rate, and he actually in his paper couldn't see any reason why that wouldn't continue. And what was interesting with the scenarios, when we analyzed them in the end, only one of our scenarios is at that 1% growth rate where you hit that Kardashev type 1 energy use by the year 3025. And that one actually has spread out of the solar system. So it's actually Kardashev type 1 and its energy use, but a much larger spatial scale than just the Earth. But we had 3 other scenarios that are growing, but slow growth scenarios. So less than 1% per year, I think 30%, there's a 10% one, I think. And, that's kind of encouraging for thinking about our future on Earth. You look at the exponential growth in energy consumption as well as population in the past, and you keep, draw that line into the future and you hit the catastrophe point. And, there's a lot of doom and gloom and panic about those sorts of things. And it's interesting to show that when we take this methodological approach, we get actually multiple scenarios where the growth rate actually slows down pretty significantly. We get 3 scenarios where growth actually stabilizes. And so you get a net zero scenario where you achieve, this, ideal sort of sustainable balance in some way or another. And then there's 2 where there's growth and collapse. And then you've got this post-collapse stable state, which is something that people talk about, maybe the transition from here to whatever future we end up in that's stable is not the greatest transition to go through. But that was only 2 of the 10 scenarios. And then there's one that oscillates on a 200-year periodicity between growth and collapse, and then regrowth and collapse. And that's kind of interesting. There was a PhD student from China who saw me talk about this, and he pointed out that Chinese dynasties have a similar periodicity historically of about 200 years of a rise and fall. And so it's just interesting that just taking our approach even revealed a pattern like that that's not so foreign to human civilizations. And so you could think about something like that in the future. So, they all have different growth trajectories. They all have different political, economic, societal, and technological factors defining them. The commonalities are just, we ruled out human extinction, and, people haven't contacted extraterrestrials yet, and there's been no new animal that's evolved a technosphere. But it's really quite diverse. Some of them, the technosphere is just on Earth. Some of them, it spans the whole solar system. Some of them, the biosphere and technosphere, aren't even overlapping. So it definitely taught me more about a range of possible plausible futures than I would have thought about otherwise, just by doing it on my own.
And it's important to think that way for not just astrobiology, but also just in general with futurism and trying to predict where human technology goes. And I've identified stuff like that before, like, well, there could be bottlenecks here, big ones. And you may end up that the reason we don't see the galaxy spanning civilizations is there's no reason to do that. And that you eventually just hit an equilibrium where you're fine. You don't need to go any further, at least until your star dies or whatever. But even then, you can sort of mitigate that if you're advanced enough. So looking for something like that as a technosignature, Stellivores, and those sorts of things. Tell me about that. The idea of looking for stars that appear to be being drained, physically speaking, and not just energy wise, actually being stellar lifted and things like that. Those ideas come onto the table. Tell me about that, Jacob.
Sure. Well, yeah, these are ideas that our collaborator Clément Vidal has developed, and so we kind of started working with Clément because we had these very sort of Earth, human-centric futures where that's by design. We're thinking about what Earth's technosphere going to look like in 1,000 years. But then, for the next step, trying to think beyond that, what's a really bizarre sort of just different technosphere that you could imagine existing, and maybe with some logical continuity to Earth today, or perhaps. But it's hard in this field, in technosignature science, to stretch your mind to imagine things that are so different from what we know on Earth. So it's at least an attempt to do that. What motivated us, we started at the beginning of this conversation talking about the Kardashev scale. I mentioned how the Kardashev scale, we call it a luminosity limit. That's the most energy you can get out of starlight. So we just asked ourselves, well, what else could you do if you wanted more energy than a starlight? And Clément had a good answer. You could eat your star. Instead of consuming the sunlight, the photons, you consume the stellar mass. Your star itself is the food. And so if you just imagined a hypothetical civilization, technological, biological, that is consuming its star. Now, you may not be able to imagine more than that about what it looks like, how it functions, but we're just trying to think at a very fundamental level where instead of a planet and civilization powered by photons, it's somehow powered by stellar mass instead. And so Clément calls this the Stellivore. And then he points out that there are these star systems, X-ray binaries, or closely orbiting, accreting binary stars that orbit so close that mass flows from one star to another. And you have some of these where you have very powerful mass flows because one star is a black hole or a neutron star or a white dwarf, one of these really, really dense astrophysical objects. And so you have very strong mass flows. And so Clément just asked, what if perhaps some of these systems, not necessarily all of them, but what if some of them are actually technological systems and we just don't know how to recognize that it's technological, but this extreme mass flow perhaps is the unusual technosignature, or at least one of them. And, you could imagine that if you were able to harness stellar mass as a food source, as a hypothetical advanced civilization, that might look something like that. And so he's got ideas of, looking for goal directedness, look for one star moving toward another so that it'll, that's its future food source when its current one runs out. Or, he had this idea of, looking for evidence that stars had been positioned to use it for navigation, like a global, GPS system, something like that. So, but it's really just trying to get ourselves out of our heads and think about what are really, exotic technosignatures and how can we learn from this set of futures and this way of thinking about the Kardashev scale to think about other possibilities. And so that's the one, what if there's civilizations that eat stars and could we look for that? And I think it's at least worth looking and we're thinking about possibilities like that.
What's interesting about that is those tend to be the places, say you have a white dwarf or a neutron star or something like that, that's, causing that mass flow. Those are the places SETI doesn't look with targeted SETI searches. They're looking at nearby star systems, sun-like stars and all that. But maybe the real gold in the universe are these really wild binary systems that are exchanging that, and that maybe we were looking in the wrong place the whole time, and that we should be looking at things like that, and also black holes for that matter. What methodology did you guys use in your scenarios, though, to try to remove an anthropogenic a bias? How did you try to de-bias that and essentially think like an alien? And I'll direct that first to you, George.
Yeah, sure. Well, that's a good question. Let's start with the first paper, for example. So there are three kinds of anthropocentrism, let's say, that usually get mixed or conflated in this in discussion. So perhaps we can a little bit disambiguate that first. So the first type of anthropocentrism would be perceptual anthropocentrism, and this is really something that we as humans cannot move beyond right now, because this is just the way we perceive anything besides the thoughts that we have in our minds through our bodies and through our thinking patterns. So this kind of anthropocentrism is difficult to remove from the equation without really including weird artificial intelligence scientists at some point in the future, perhaps, who might not be thinking like humans, or even in the longer term future, some sort of animal kind of scientist. So that would be one way to go beyond that, but in our case, that would be difficult. The other way, the other two aspects of anthropocentrism that might be removable, let's say, from this equation are descriptive anthropocentrism and normative anthropocentrism. And descriptive anthropocentrism really is in the sense that whenever we try to make sense of some sort of phenomenon, let's say, we just compare that to something human related based on our experience. So sometimes this happens in cross-cultural comparisons, for example, when you say, well, this is the equivalent of this thing that we have in our country. So just using the human or whatever humans create as a reference point, just to make sense of things that are out there. So in that sense, sometimes this sort of descriptive anthropocentrism is handy and useful to make sense of things. The other kind of anthropocentrism, the third one, which is also removable, let's say, from the equation, it is something that can be overcome, is normative. And normative anthropocentrism in that sense would be that there is some sort of a law, let's say, or a rule built in the structure of the cosmos, or somehow just permeating, let's say, anything humans do, but also other things do, and humans are part of that. So then you do not just evaluate other things with respect to the human as a frame of reference, but you really assess and ascribe different levels of value, perhaps, or primacy of values, or even morally, or from a deterministic standpoint, let's say, put things in an order, let's say, or a scale similar to what the great chain of being was doing in the earlier stages, let's say, of Western science, drawing from Aristotle's philosophy. So this thing was removed, let's say. So in our case, we removed normative anthropocentrism from the scenario development process, because we were not stating that human technology is following a rule. For example, like a progressionism philosophy that would say that, well, for sure, human technology will need to evolve like that. So that part was removed, and also the ethical aspect that human technology is better or superior, morally superior than other things, that was also removed. So this was not part of the equation. But descriptive anthropocentrism, in that sense, was actually part of the plan. So we were trying to use the potential technosignatures of the Earth's technosphere 1,000 years into the future as analogs for the technosignatures of other technology-capable extraterrestrial agents. So in that sense, we were using descriptive anthropocentrism as a vehicle to be able to understand what diversity of technosignatures might exist out there. So that's a long answer to the short question about how to remove anthropocentrism. But given that part, then, the method we followed is pretty standard in the future studies literature. It's called morphological analysis, originally actually developed by an astronomer, Zwicky, who was trying to figure out in a combinatorial sense what other kind of astronomical phenomena might be out there that have not yet been discovered. And he was trying to explode, let's say, or decompose the existing astronomical phenomena into their constituents to figure out whether there could be other combinations of these parameters, of these factors, that could lead to a creative inspiration, let's say, to look for other kinds of astronomical phenomena. And then he also applied that to rocket engines, for example. So this is a pretty generalized method, a morphological analysis, to analyze complex problems into the factors that comprise these problems, and then analyze these factors exhaustively into the potential values each factor could take. And then this produces a multidimensional solution space, which contains a lot of solutions for the problem that we had. In our case, we really had thousands. I remember just thousands of potential scenarios.
5,760.
Which is very difficult for humans to look deeply into. But there are, of course, other systematic methods like cross-consistency assessment, for example, where you go and evaluate each of the pairs of values that each factor could take and rule out some of them that might be logically inconsistent or really physically implausible at all. So you just remove these pairs, and then each time you remove a pair from this multidimensional matrix, a whole scenario line collapses. It is just completely removed because it's a chain. It's like a chain of values or factors that each scenario is made of. So in that systematic way, with Jacob and our collaborators, we worked through these pairs, and we narrowed down the scenarios from over 5,000 scenarios to this manageable set of 10 that we had. And then from that point onwards, it was easier for humans to actually work with that, given the original set of assumptions that we had, that Jacob mentioned before, that it is humans who are the creators of technology. They have no inspiration, let's say, or they have not received any sort of technology from extraterrestrial agents, because all these would be wildcards and it would be difficult to factor them into our analysis. So we also had these sort of assumptions, and then we followed a structured world building pipeline that we created for this particular project using McSniff's published set of basic human needs, which is, again, published literature. McSniff was an ecological economist. He worked a lot on trying to figure out what kind of basic human needs might be there that could be used for human development purposes, similar to what Maslow did, which is a theory that is more widely known. But McSniff's was a very structured theoretical framework that we integrated in our world-building pipeline. And through that, we were able to start crafting these worlds in a way that would be logically consistent for them to exist. Because we were following a paradigm that was saying that human needs and human technology co-evolve. So it's not that technology just follows from the human needs, and it's just not just that technology just relentlessly pushes towards the future and human needs just follow. It is that these two things co-evolve, so they need to have some sort of a common underlying thread binding them. And this also helped us in our world building. These are the myths and metaphors that we use to bind, let's say, the technological aspects of future Earths with their more institutional aspects, social, economic, political aspects, make sure that logical consistencies followed across while we were generating these worlds, to go deeper into what kind of technosignatures might then be produced by these worlds that are self-consistent. It is actually like a reframing experiment. Like each world can be read. That was our aim, for people to be able to read these worlds, and then their assumptions would be reframed by the logical consistency, let's say, of these worlds, that they seem plausible, they could exist, possibly, in the solution space, and then their assumptions are reframed, and then the possibility space, let's say, of what are we going to look for opens up a little bit.
Now, Jacob, one thing that does seem to be a factor that I don't know that you could get past would be physics. In other words, an alien civilization is going to have the same physics we do and be constrained by it. In short, there's only one way to build a radio transmitter, or something like that. You're not going to do that with anything except, something that resembles our technology in some way, which means that there would be a common understandability. Do you think that's important in looking for technosignatures? Is that what could possibly be the commonalities that define one civilization that can actually detect another one?
Oh, absolutely. There's a couple things I can say with that is, one, the only common language we will have with any technological civilization that might be out there is anything that's overlapping. So, if there's another technosphere out there, but there's no overlap, you can think about it like Venn diagram overlapping circles, right? If we've got some overlap, like we both have radio transmitters, or we can both talk about the hydrogen atom in a meaningful way, or something, then there's some way of interaction. If those circles aren't overlapping, there may be so little overlap that we can't even perceive them, or just enough overlap that we have some way of perceiving them, but then that's all. And so, yes, you have to, if we're looking for technosignatures, it has to be a technosignature that at least we have the ability of recognizing, which, could be something like Stellivores, like we just talked about, where it's weird, it's anomalous, but it's different than us. But then, yeah, certainly something, the sets of technologies that exist on Earth today and that are plausible are the ones that we know about, and we have a better chance of recognizing, if we see them. In our scenario set, we obviously cannot imagine technologies that are unimaginable, right? This is a paradox of the first type of anthropocentrism George mentioned. I can't get out of my human head. But, we had one scenario that had a quantum beacon, which is in the literature, but that's also very difficult to search for. There's some ideas, but, how would you recognize a quantum signal if you didn't know it was there and you didn't know how to decode it? Might be tricky. But looking for radio anomalies, we have a better sense of how to do that. And then so, there's the idea that, of course, antiquated technologies can still be around. And so in many of our scenarios, and again, these are 1,000 years into humans' futures. So it would be pretty difficult to imagine that radio goes away entirely. We're still burning wood and coal more than ever on planet Earth, even though we have other more sophisticated ways of using energy. And so in the same way, you don't imagine that radio may go away, especially in 1,000 years. And in some of the scenarios, the radio channels, the bandwidth is totally saturated. And so you have optical and other modes of communication that develop in response to the overcrowding of the spectrum. And so in that sense, radio remains a pretty good technosignature for many of the scenarios, in addition to some of the other technosignatures that emerge, because although we've had radio for a long time, it's hard to imagine radio really going away. Even though some people talk about, we have fiber optic cables, things are going to go radio quiet. There were only some of our scenarios that went in that direction, and many of them actually got even more radio loud, just even though other things changed, radio didn't go away. And so, yeah, we have to use the technosignatures that we know about, at least as a basis for defining our search, while then being open to discovering other types of anomalies.
The electromagnetic spectrum does not go obsolete. And as you mentioned, fire. Well, fire is a property of nature. At least here on Earth anyway. And as long as you've got the right gases for it, you use it forever just because it's the best thing. You stumble across the best idea first. And with radio, I cannot imagine an alien civilization that would see radar as obsolete, especially when you're radaring asteroids, very high powered radar and things like that we used to do at Arecibo before it collapsed. Why would you go to another method when that's cheap and easy and works? If it's not broke, don't fix it. And I sort of agree there that radio will not go obsolete. I don't think that there's a way that it would, because it's just too useful. It's like saying light goes obsolete. Well, no, not really.
So in our one scenario, I think it was scenario S4, this is a post-collapse scenario where, it's maybe a little bit, living like the Amish in a sense. Living with the land is the name we gave. We gave these metaphorical names to each of them to kind of convey a sense of the underlying myth governing each world. And I think that was one of them that was the only one that had no radio, but it was a collapse. And then in the rebuilding, humanity lives at, slightly above subsistence level, but very rudimentary technology. But in the other 9, even the other collapse one, radio survives.
But in that specific scenario, there is no technosignature there. If you had a planet that was pre-industrial, effectively, or post-industrial, if you want to give it that term, after the collapse, there's no real way to see that other than maybe remnant gases that were from the technological part of the civilization but those go away eventually. They break down, the CFCs and all that. So just you wouldn't you go quiet in that scenario?
Yeah, it would be difficult. That was one of the interesting conclusions that came out of this work, is we had several scenarios in which the Earth itself would be indistinguishable from nature, so to speak. If you were pointing your, James Webb or the Next Generation telescope at the planet, doing the spectral analysis, look at what gases are in it, anything like that. There were a few where the Earth really is in the same condition as pre-agriculture, not even just pre-industrial, pre-agricultural Earth. And so in that sense, if you were to study this the way astrobiologists are interested in looking at exoplanets, you might say, oh, that's a planet that has some biosignatures. It's a planet that it might have life on it. And you would miss the fact that there's technology on it. Now, this one, the living with the land, scenario number 4, the technology is pretty more rudimentary. It's not that there's no technology, but it's much more basic and probably the kind that you would have to at least be in orbit around the planet, with a remote observation or something to really notice that, oh, there's some cities and structures and things that have been built there. Some of the others, have technology across the solar system, but Earth itself is in this pristine state. And so you would have to do some other kind of exploration, whether that's being able to notice that Mars or Venus has been altered, or again, send us a probe to go visit. So yeah, there were several scenarios that, even though there is technology present, whether simple or advanced, Earth itself would look pretty indistinguishable from Earth without technology, unless you're looking really carefully and maybe close up.
Good way to hide Earth. Misdirect.
That's right. That's right.
Aliens invade Mars. Yeah. Don't look over here. Now, new technosignatures, new ideas for things that we could search for that come out of these papers. Was there anything new that you guys had identified that we hadn't heard before as far as technosignatures go? And one of them I noticed that you cited in the paper was a signature of satellites burning up in a planetary atmosphere. And I suppose if you get enough of them, you would see those metals or whatever, and it wouldn't quite look right. Could you explain some of those new ideas on what we might look for?
Yeah, I mean, we were trying to be comprehensive. The detectability is a separate question, but on Earth today we have lots of satellites in orbit, and we have satellites that get deorbited, and they deorbit, they burn up in the atmosphere, which is great because then they don't crash into anything. But we are finding that the matter in those satellites becomes, aerosol in the atmosphere that eventually then falls to the ground, and you can collect it and analyze it and recognize, like, oh, there's metals and other elements that were originally from an orbiting satellite. And so I think, as of now, detecting such a thing with a James Webb Space Telescope kind of instrument in an exoplanet atmosphere is very, very, very far into the future. Like, we're not going to do that with today's facilities. But, we were just doing this sort of for completeness and thinking about all the technosignatures. And of course, maybe someone thinks of a way to do this. But in any case, if you were to observe something like that and it wasn't from Earth, that would be a very compelling technosignature. And then, of course, the inverse, just thinking about what are the ways that we today are influencing the biosphere with our technology. What is the physical extent of the technosphere? That's just an interesting thing to recognize, that our technology is actually affecting the composition of our atmosphere, and not just talking about carbon dioxide accumulation, but actually putting metallic aerosol into the atmosphere. So I think that's interesting. One of the lessons for the search for technosignatures in general, there's sort of a technical and then sort of a sort of more broad philosophical conclusion that I can just articulate quickly. The technical one is we propose that all of these scenarios have a wide range of technosignatures that all appear in different combinations. You have some with asteroid mining and Kuiper belt mining, and cities that the city lights have been directed downward to not scatter outward. And so there's an underlying mythology, like not mythology in the sense of, gods and characters, but like a myth or an ethos or a metaphor that sort of defines the world at the deepest level. So, we have one called Big Brother is watching you. I don't have to describe more about the world for you to just get an idea in your head and what that's like. And if I told you that one world is Big Brother is watching you, one is transhumanism, already you can imagine that there's going to be different decisions made in those worlds that have different outcomes, not just on how people live their lives, but then what the technosphere, the detectable technosignatures might be. And so one thing that we offer from this is that all 10 of these scenarios provide different examples of plausible technospheres across the full electromagnetic spectrum and other technosignatures. And in astrobiology, we've been doing this for biosignatures because we have Earth's history. We have Earth today, we have early Earth in the Archean, we have the Proterozoic period in Earth's history, and Earth looked different at all those times. And those provide sort of just a ground truth for how to search with a telescope for those kind of biosignatures. So that's one of the valuable things from this scenario set is we've got not just turning the knob of pollution and seeing if you have a lot of pollution, could you find it? No, here's 10 case studies. If you just imagine these being exoplanets and you're observing them, which ones of these could you see? And that's actually the next step that we're working on now is, how many hours with the Habitable World Observatory, for example, would you need to find technosignatures or not on any of these worlds? And then so that relates to the second lesson, which is just broadly thinking like maybe Earth-like technospheres are not necessarily a bad place to start for thinking research. Again, returning to Kardashev, do we need to be thinking about a civilization that's using all the energy from its star or a civilization that's spanning the galaxy? Like if they exist and if we can find them, I'm in favor of it. But if perhaps it's also reasonable to think that technospheres, even if they're abundant, grow perhaps at a slower growth rate. Maybe they expand across their solar system at more so rather than increasing their energy use. So prioritizing exploration over exploitation is one way to look at that. And so, these are all 1,000-year futures. They all look pretty different. There's some similarities, but there's a big range of differences. And so, maybe Earth-like technospheres are a reasonable place to start. Some of these could be long-lived. They might last for millions of years instead of 1,000 years, and we've just got a snapshot of 1,000 years. Or they could be like popcorn. They go in and out, but they're the most common type of technosphere, so it's the one we're most likely to find. So we can certainly think about the more rapid growth civilizations as well. But I think it's a good lesson to just think about the fact that we can imagine a lot of exotic, slower growth technospheres just from Earth alone. And it's worth entertaining the possibility that that's what might actually be there waiting to be discovered.
How does time factor into this? So one thing that we do know, and this was first advanced by Frank Drake, I believe, in an issue of Cosmic Quest magazine, which was a defunct SETI magazine from the 1970s, that we don't know what time frames they function on. So in other words, if they function on a slower time scale than we do, they may only signal each other once every 200 years. And that maybe we're actually really fast for a species in our ability to react and move. But, the tree people of, whatever planet might be on a completely different time scale. Can that be accounted for in any of these scenarios that, it may take a civilization much, much longer to get anything done, even if it is technological?
That's a very interesting point. It relates to the sort of perceptual anthropocentrism or other kind of perceptual species centrism in that sense. So it is difficult perhaps to actually to search with targeted searches when there is a deep difference between the so-called worlds or Umwelten, as sometimes they are called in semiotics, like the worlds that different agents perceive and the kinds of things that are afforded to these agents by these worlds. So it's not just that they perceive them, but these worlds afford things. And one of the things that can be afforded in different ways is communication. So essentially agents that have significant perceptual difference, let's say, for example, differences in time perception, then humans might be operating in Umwelten, so in worlds that are not that much overlapping with humans. Although in the scenarios that we worked on, one of the things that for sure could be used to that end is that serendipitous discoveries might also happen sometimes. It doesn't have to be that a discovery is made because, or a detection, even like an early stage detection before it is a confirmed discovery. It takes place because people were actually searching for that, but because of they accidentally found an anomaly, and then this detection kickstarted a whole cycle of scientific interpretation and validation and discussion about whether this is actually a thing or not. So perhaps through these scenarios, we might be able to offer at least some initial inspiration or reflection space for people to be able to anticipate serendipitous discoveries and not so easily dismiss, let's say, some anomalies that might point towards this sort of, let's say, detection of technosignatures where there is really big difference in temporal perception. And the other thing that for sure the scenarios offer is that whenever someone suggests or proposes a new kind of method for detecting technosignatures in the literature, there are usually some assumptions that are embedded deep in that idea, and these do not surface so easily. So making them explicit also helps. And this, what you stress here, John, is an important assumption that sometimes also goes unnoticed. And I think we also call for that, to be able to trace our assumptions that drive the ideas that we put forward for searching for new technosignatures. But as for targeted searches towards this sort of temporal difference, perhaps Jacob, you might have another idea. But yeah, if the worlds do not overlap that much, then it might be one of these graveyard civilizations. Yeah, I don't know. Jacob, perhaps you had another idea, but
Like how we could search for graveyard civilizations is definitely a tricky question. And so, I mean, that could be a future extension of this project, but yeah, no, that definitely gets trickier.
It does until you're on site and you start seeing things like right angles in the geology and, concrete. Things
Well,
like that.
no, so this does get to one of the conclusions as well of what we've done. And then, I mentioned we're doing a paper where we're trying to do the detectability studies, and the spoiler is it's a little gloomy in terms of, if you want to find a technosignature, great. Let's come up with a case where the James Webb Telescope can find it on Proxima Centauri, TRAPPIST-1e or something. That's great. But yeah, most of our scenarios, the easiest way to find the technosignatures is to send a probe there to visit, whether it's a person in there or just, a remote probe. But like to get up and close, the way we explore the solar system planets, and, you have to be very patient for that because of the distances involved between stars. You have projects like Breakthrough Starshot, things like that. But I mean, that may be the reality that, like, unless you get lucky and you find, radio waves that are being beamed towards you at the time that you happen to be looking. The best way of finding technosignatures, may in fact be to visit, and that might be the easiest way to notice Earth's technosignatures. That may be the best way to find all the technosignatures that might be in the galaxy, even if they're not anywhere resembling our scenarios. And so, yeah, it could be that finding biosignatures by looking for gases in an exoplanet atmosphere might be compelling, and maybe looking for technosignatures that may not be the way to give you the highest degree of success. So that's not necessarily encouraging, but if that's the method we need, then that's the method we need.
The fun thing, though, about ideas like Breakthrough Starshot is that it in itself is a technosignature because you need a giant laser to drive those sails. So you've got this.
That's right.
You've got this giant laser, and
if the laser's pointing toward you,
if it's pointing towards you, it means you're going to be visited by at least a microprobe. But there's also the idea.
No, I have to say, when you started your question here just about the different lifetimes of organisms, I mean, I have to mention, Lord of the Rings. I love the Ents, the tree organisms, the tree creatures. It takes them like an eternity to pronounce their names, or their meetings. It takes days just to say your name. And
don't be hasty.
I think it's certainly worth thinking about such things. Right. And we don't know. So one of our weirder scenarios where the biosphere and technosphere have sort of separated it's a deus ex machina. And so there's a technogenesis event. AI has become self-directed and self-governing. They've spread across the solar system, but humans have remained on Earth, restored it to a pristine state, and then AI has gifted humans this net zero technology that allows us to live and maintain a pristine Earth. And so, but the AI entities are sort of living these like infinitely recursive digital existences. And so, you have trillions of entities that are individuals, and you just sort of imagine yourself in like a perpetual series of virtual reality simulations, living as many different kinds of lives as you want. I mean, that's probably, one of the more bizarre places the scenario development process took us. It's a thing I can articulate. I can imagine it within my perceptual anthropocentrism, but it's still pretty out there, and it's still certainly imagining a kind of life that would be pretty different for Earth, and maybe again difficult to detect without actually being there on the planet to see the infrastructure.
And that's why I think that we need to do, a lot of people will make the argument that we've been doing SETI for 6 decades and we haven't seen anything. There must not be anything out there. No, I think you need to do it for centuries and centuries
Oh yeah.
and centuries
Oh yeah.
because of the time factor. And that worries me, is that we might, we don't just have the distance problem, we have the time problem as far as detecting alien civilizations. And coupled with that, again, is that we may not exist at the same time as another civilization in this galaxy. So that, that gets back to your necrosignature, where it's, dead alien civilization out there somewhere, with their Voyager 2s or whatever, just, flying through deep space. But there is also the idea of the von Neumann probe, and that if you have extreme longevity, it doesn't matter if it takes your probes 10 million years to move through the galaxy, which brings us to close technosignatures, potentially things that we might find here and be able to study here in this solar system. And that's especially poignant because it certainly looks like that we're going to be able to study the geology of other star systems with these interstellar objects that keep cooking through. Well, what if that's the way to go? So did any of your scenarios speak to close technosignatures?
That is a great question, and that is a future development that we are trying to do. If anyone's listening and they want to fund this project, that'd be great. But either way, we're gonna, find a way to do it. But yeah, the idea to, you could think about it, and George will have some, comments here, I'm sure, is just thinking about any of these 10 scenarios, almost all of them probably, maybe not the total collapse one, but if they were to then engage in interstellar exploration, then what would that look like? And then we can think about, if we were on the receiving end of a civilization like that doing, physical in situ exploration, whether that's to explore, whether that's intentionally to send message or make contact or anything like that. Again, the motives are going to be different for each scenario, and not just the technological capacity, but also the reasons why they would do that, and that may inform what their solar system Earth exploration programs would look like to us. And I think that would give us some deeper insight into where to start looking at our solar system rather than just kind of the limited shotgun approach we've had so far.
George, your view?
That is true. Yeah, this also points to the value of doing this kind of work, right? It's this reframing value of the scenarios that I mentioned before. It's exactly that. So it doesn't have to be a singular explanation. Sometimes we tend to try to figure out a singular grand theory that could perhaps explain why an extraterrestrial civilization might decide to spread everywhere or in some parts at least of the galaxy, or grand theory that would explain von Neumann probes. But there could be different ways that this could happen, and reframing our capacity to think about these ways might help us actually look for them if we want to look for them in a targeted way, but also detect them serendipitously. And this sort of reframing can be continued by this idea that Jacob mentioned. Well, nowadays Earth, for example, is the receiver, let's say, of some material technosignature, an artifact that is coming from any of these 10 future worlds. So again, we leverage the 10 scenarios as analogs because we are wielding this sort of descriptive anthropocentrism to our benefit, just to showcase that with these examples that are arguably tangible, let's say, even the 10,000 year scenarios of Earth's technosphere are arguably tangible. You can sense whether they are logically consistent or not just by reading them. We can figure out alternative explanations for why or why not some of these 10 different worlds might reach Earth as a receiver, and this could help us expand a little bit our theoretical repertoire as well, right? You don't have to subscribe to a particular reasoning why von Neumann probe might want to. It doesn't have to be, a self-replicating, a paperclip optimizer, or some sort of a singular narrative. There could be other regions, could be different kinds of these artifacts, and we want to get this sort of pluralistic thinking back into the equation again, to show that we should not be that quick, let's say, to dismiss these sort of ideas just because some grand theory might have some holes. There might be other ways for why such things might actually be good ideas that are worth looking for.
It's interesting to think about the idea, as we were talking about with the Stellivores. It occurred to me that if you have an area of the galaxy that is devoid of stars and it's growing, like a void inside the galaxy, that would look a little bit strange. I mean, there are star-poor regions, but not like this, where you had this expanding bubble of altered stars, or stars changing. Because if you start removing mass from that, you're going to change that star's type eventually. And you would notice that if you looked long enough. And unfortunately, that gets back to the time thing, because a lot of the technosignatures I've thought of would take thousands upon thousands, hundreds of thousands or more years of observation to even notice, like terraforming. If you see a planet changing, you're going to have to watch it for a very long time. My last question, gentlemen, and it's very important to rethink this. It's there hasn't really been a rethink since Kardashev, and finally we have something where it reframes the question in a useful way. And there will be links to the papers in the description below. But my last question is this: throughout, a major question in astrobiology is the idea of great filters. And some of them could be technological, but this isn't a filter. It's just a profound change that could happen, and that's the so-called technological singularity. And if such a thing occurs, which I'm not sold that it occurs as it's often portrayed, if such a thing occurs, does that change all of the scenarios? Meaning that having an infinitely intelligent AI that can invent everything for you at once, does that just change everything if that indeed happens?
Well, we have at least one scenario where something like singularity happens. Yeah, it's like a spark, let's say, of technological life, and we do have these sort of post-human entities. That this is what Jacob mentioned. Is the scenario that Jacob mentioned before? The sort of post-human entities that do get the technosphere towards another direction. So we do have at least one scenario where this happens. But if this happens earlier, like 15 years from now, and not yet in the time horizon that we looked at for this particular project, then this essentially violates one of our basic assumptions, which was that humans are the only animal species, let's say, that creates the technology that is available on Earth. Even if these post-human entities occur later on, they are still the outcome of human creation. So the way that the scenario evolves, you see that this is not some sort of misaligned, malevolent super intelligence that just thinks that humans are scum and just goes on and deletes human presence from Earth. But in that scenario, there is an inherent assumption, perhaps, that at least these entities are either indifferent or they are benevolent, let's say, towards humans. But one particularly important change that would really change the scenarios for 3025 is whether in the next 20 years, perhaps, we do have some sort of an outcome of a technological singularity where there is some sort of malevolence towards humans. That would definitely, change a lot of things, for sure. This is a parameter that perhaps needs to be explored later on, which also points to the need for recording one's assumptions and working from these basic assumptions, these premises onwards and building on these, and always keep track on what you consider as your foundations, let's say.
I think the scariest thing that could happen, and I'll weave a scenario, but it's not one that's very relevant to what we're talking about, but it's a possibility that if you spot alien civilizations through a SETI experiment, whatever it is, and you see that civilization, say you just happen to catch it right when it's roughly our level of technology, and then you watch it for 100 years, and by the end of that 100 years, they're building a Dyson swarm and obviously moving much faster than you are. Maybe they had a previous civilization that collapsed and then rebuilding it, something like that. That might motivate you then to do the same thing, to not be one-upped, or for security, if close enough. And all of a sudden you end up with all these civilizations watching each other in an arms race, essentially, or a technology race. And that's how the end of it is that you end up with a Kardashev type 3 civilization because everybody became Star Trek because they were all watching each other and copying.
I like that thought. So I have a couple of things. First, what I'll say to that is, if we can continue an astronomical program for a continuous 1,000 years to get that kind of data, then we are on the right track to compete with that civilization, because that's the kind of long-term thinking that we, in long-term project execution, we're not good at as a species now. So I would say that's a +1 in our favor. If we even detect that and we're convinced by it, we're on our way. And I think your point is, this is speculative, but I think, it's technosignatures. Everything's on the table. I'll have a laugh and then I'll entertain these ideas because I think it's worth going there. Writing was invented twice independently, at least, possibly more, on Earth, on human civilization. And it seems from what the data is that, writing in China and writing in the Middle East arose simultaneously, and it might have been that somebody came from one place, whichever one did it first, some traveler came back and said, hey, they're doing this thing where they put symbols on tablets and it means stuff, and you just needed that the knowledge that a thing was conceivably possible, or even something like running a mile under 5 minutes was thought to be impossible. Somebody did it, and then many people broke the 5-minute record for running a mile. So there's countless examples of this. If we just broadly, if we see a technosignature, something we think that's a technosignature, that's going to give us ideas for something to do. And like you obviously, yes, if we find recovered alien technology somewhere, great, we can reverse engineer it. But if we see a spectral wiggle of a line in an atmosphere that tells us something about the possibility of an alien industry, existing, hundreds of light years away, that's also going to inspire us by just knowing that a thing exists. And maybe a kind of a good concluding thought. You'd mentioned the great filter. If we find, technosignatures, we find good, compelling evidence of extraterrestrial civilizations. Like, okay, maybe we get in an arms race, but I think there's huge distances between us that make that not an immediate threat. And meanwhile, just knowing that they exist, I think gives us hope to continue our future trajectory in whatever form that is, because we know that since they exist, it's not necessarily an insurmountable obstacle to get from where we are to where they are. If we observe them building a Dyson sphere in 100 years, we know it's possible to build a Dyson sphere in 100 years. What else is possible? Let's figure out how to do that. So I think in that way, finding technosignatures is inspiring. It gives us a sense that we have sort of a longer, more open future than we might otherwise.
On writing and independent discovery of it, you mentioned China and the Middle East. However, it always blew my mind that, okay, they appear about the same time, and the writing spreads and, but not that long after, it appears independently in Central America. I mean, there is no commonality between Mayan glyphs and any other form of writing, but there it is.
Yeah, it's amazing.
All within a short time, all of the humans globally.
Yep.
Revolutionized, even if they didn't have contact with each other.
Yeah.
And you wonder about that too, like explosions of intelligence and things like that in the universe, that maybe we're just a little bit early, and that this will get very interesting in 10 million years or 100 million years or billion years.
Yeah. There's the idea of phase transitions in all kinds of systems. And yeah, maybe we just entered a phase where technology is now possible or more likely in the universe than it was previously. And we're on that first wave. Totally possible.
Hopefully we don't end up being the necrosignature that everybody else finds. And they're like, oh, the ancient ones. It's the humans.
Well, our scenarios partly help inject some optimism. You know, people ask me, which one do you want to live in? Which is your favorite? I don't have an answer because none of them are perfect. And that's why they're useful scenarios, because they're not utopias. But there are some that are more encouraging than others. And I think that's important to inject into the discussion about Earth's future, too, as well as technosignatures. Just, it's not all exponential growth. It's not all collapsed. There's a big space in the middle. And, you know, let's hope that's where we land.
And, you know, to end on a high note, the very fact that you would see a technosignature of an advanced civilization that's very likely much older than you are, statistically speaking, means that you can do it and that there isn't a filter if you play your cards right, and that maybe you eventually hit a point where you no longer can go extinct. You know, you've spread to multiple planets and all of this, and that that could, I would think that would be a unifying force on this planet if we saw aliens that were actually doing well out there.
I think so. I mean, that's functional immortality, at least as much as you can get as a species.
All right, gentlemen, thank you for joining us today, and I hope you'll come back as you continue your work, because this was fascinating, and I really support the idea of a retake on our ideas of what alien civilizations could be like.
Thanks so much. Really appreciate it.
Thanks for the great discussion.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.